So now the question becomes, why have we been doing this? We've been doing all these practice problems, we've been working on all these different types of things, and why? What's the purpose? What's the idea? What is it we're really trying to get to? Well, what we're really trying to get to is this idea of limiting and excess reagents. Ooh, reagents, that's a new word. Well, swap out a letter. Reagents is just another word for reactants. Now, in the lab, we looked at what a limiting versus excess reagent or reactant means, and we found that a limiting reagent or reactant is a reactant that limits the amount of product created during a chemical reaction. It is, in essence, the ingredient or the substance that gets used up first. Now, if the limiting reagent, the limiting reactant, is used up first, that means the other reactant would have to be your excess. It's the substance that is not used up completely in our chemical reaction. It would be the leftovers, the substance that's going to hang out. It's not all going to be used. Well, that's important to us. Now, it may not seem like it, but it really kind of is. If you're baking cookies and you run out of eggs, you can only make as many cookies, you can only make as much product as your eggs let you. It becomes, as I like to refer to it, as the boss. It's in charge, because once it's done, reaction stops. You can't keep going if you're out of stuff. You can't keep making a sandwich if you're out of bread. You can't do it. The limiting reactant is going to control our reaction. So if we can find the limiting reactant, we've got the boss. We've got the guy in charge. So let me show you how we go about doing this. So let's say we've got a reaction, and given the following reaction, sodium plus fluorine equals 2 sodium fluoride molecules. If we were starting with 5 moles of sodium and 5 moles of fluorine, we want to know which would be the limiting reactant. Well, we've got two substances here. We've got sodium, we've got fluorine, and one of them's going to run out first. We don't know which one, but we know one of them's going to. It has to. That's just the nature of chemistry. One substance gets used up first. So what we're going to do is we notice we've got two sets of numbers given, which means we actually have two problems that we need to do. We've got 5 moles of sodium, and we have 5 moles of fluorine. Now, to keep those in line, let's just put them both over once. We know they're two separate problems. So, we've got two separate problems. We've got the moles of sodium, moles of fluorine. One of them is going to run out first. We don't know which. Let's see if we can figure it out. Well, let's just, for a moment, let's assume, or let's suppose that the sodium was the limiting reactant. Could we, using what we know about our stoichiometry, figure out how much sodium fluoride our sodium could make? Well, sure. We know there's a relationship between sodium and sodium fluoride. That relationship is a mole ratio. The ratio here is 2 to 2. Okay, let's change moles of sodium into moles of sodium fluoride. Well, when we do this, we see it's a 2 to 2 ratio. For every 5 moles of sodium, we get 5 times 2 is 10, divided by 2 is 5. We'd get 5 moles of sodium fluoride. Moles cancel. We're into moles of sodium fluoride. Cool. So if, and we don't know if it's true or not, but if we started with our sodium and it's in the boss, it could make 5 moles of sodium fluoride. Now, what we're going to do is we're going to do the same thing for our fluorine. We're going to take the moles of the fluorine, separate problem, moles of fluorine, and change that into sodium fluoride as well. We just want to be able to compare. So let's go ahead, we'll set up our ratio now. Now we're going from fluoride to sodium fluoride. Well, if our fluorine is on top right now, we'd have it for every 1 mole of fluorine on bottom. We'd have 2 moles of sodium fluoride on top. Moles of fluorine cancel. We're into moles of sodium fluoride. In this case, 5 times 2 divided by 1 is 10 moles of sodium fluoride. Whoa, this is huge. Look at what this means. This tells us that if we started with 5 moles of sodium, if all 5 moles reacted, we could get 5 moles of sodium fluoride. That's what that means. Now, let's say we start with 5 moles of fluorine and all 5 moles of fluorine reacted, it could make 10 moles of sodium fluoride. Well, okay, one of these things is not like the other. One of these things just doesn't belong. Which amount is smaller? Well, it's the 5 moles. 10 is more. Now, when we have a reaction, we need to have both substances. So what we can say is, okay, if all 5 moles of the sodium react, it can make 5 moles. If all 5 moles of the fluorine react, it can make 10 moles. Well, we're not going to be able to make 10 moles because before we make all 10 moles, we run out of moles of our sodium. What this means is that we can only make as much sodium fluoride as our sodium lets us. We have the boss. For this particular problem, the substance that makes the least amount of product is our sodium. We would call this the limiting reactant, or LR for short. Cool. What does that mean? Yay! It's the limiting reactant! Sodium, ding, 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 ding. Big whoop. What we now know is the boss. We know who's in charge of this reaction. Now we know how much product we can actually get. So let's take it a step further. If we have 5 moles of sodium, 5 moles of fluorine, how many grams of sodium fluoride are we going to be able to get? Well, just a moment ago, you told me that the 5 moles of sodium are actually your limiting reactant. They're going to run out. And once they run out, reaction's done. It stops. Kaput, kapooty, nothing. So if we have to do a calculation, we're going to start with the boss. It's in charge. It's the limiting reactant. We're not going to worry about these 5 moles at all right now because they're excess. We're not going to use them all. That's like the extra flour we're going to have with our 1 egg. We're not going to need it all. So we're going to figure out, based on our limiting, how much of our product can we actually get. Well, okay, we're starting in moles. One thing we do with moles is change moles into moles of our new substance. Well, if we read, we're looking for how many grams of sodium fluoride are produced. So we're looking for, ooh, yay, technology. There we go. Grams of sodium fluoride are produced. Okay, well, we're in moles. Let's change into moles of sodium fluoride. Mole ratio here is 2 to 2. For every 2 moles of sodium on bottom, we have 2 moles of sodium fluoride on top. Moles of sodium cancel. We're in moles of sodium fluoride. Oh, we're so close. We're trying to get to grams. Well, moles to grams, we're going to use the molar mass. We take 1 sodium, 22.99, add it to 1 fluorine, 19.00. Our 1 mole of sodium fluoride is going to go on the bottom to cancel the moles. Our 41.99 grams will go on top. Moles cancel. We're into grams. Multiply the top, multiply the bottom, divide them. Looks like, ooh, let's just get an answer real quick. 209.95 grams. Here's the trick. We've only got one significant figure. Well, here's the one we get to keep. What's the 0 going to do to the 2? Well, it's not going to do anything, which means this is going to round to 2. But we still need these. We just can't have them count. 209 doesn't round to 2, it rounds to 200 grams of our sodium fluoride. Once you've found the limiting reactant, you have found the boss. It's in charge. Any calculation you do, you start with the boss. That's all you use. Now that we know how to find our limiting reactants, I'd like for you to try one. For tomorrow, here's your homework. I need you to tell me, in this situation, which of the 2 reactants, either the arsenic or the oxygen, is going to be the limiting reactant. This is your entrance ticket to class tomorrow. Make sure you come with one of these 2, either arsenic or oxygen. You tell me which it is. That is your homework for tomorrow. Ladies and gentlemen, thank you. Have a great day. We will see you soon.